So welcome to JUMA'S Academy, and today I'll be taking in chemistry 1000 or chemistry 1010, and we'll talk about balancing redox equation questions. So my name is Tuta Juma, and today I'll be taking you in this topic. So redox equations, they're very important, okay, because some of you have started doing electrochemistry. So, as you have started doing electrochemistry, I can see in many groups lecturers are on electrochemistry. Electrochemistry deals with redox titration or redox equations. So, it is very important that you know how to balance these redox equations because it won't only be beneficial for stoichiometry, but it will also be beneficial for electrochemistry. Okay, so it's preparing you for both electrochemistry and stoichiometry where we have electrochemistry in your test two. Okay, so now uh, the first question. So it's saying that using the oxidation number method to balance the following equations. We're supposed to use the oxidation number method to balance these two examples that we have as our what? As our equations for the redox reactions. Again, there's another question here which says use the half cell reaction method to balance the following equations. We have these two equations, and then we are being told that we're supposed to use half cell reaction method. So there are two types of methods which are used in the balancing of what redox what equations. The first method is known as oxidation number method. Then the second one, it is known as half cell reaction method or the ion reduction method. So depending on which method they tell you to use, if you use the other one, they will mark you wrong because they've specified the type of the way they want you to balance it. Okay. So we have a question here saying that use the oxidation number method to balance the following equations. We have this equation A. So this question came in the same paper which I was talking about, where the question is for the redox titration. This question came. So I want us to look at this question. Then after that, we'll go to the next one. Okay. So we have equation. So they want us to use oxidation number method. So we have A. So for A, we've been given aluminium, which is a solid, plus sulfuric acid, sulfuric acid, which is giving us sulfuric acid, which is giving us aluminium sulfate, then aluminium sulfate plus hydrogen what? Hydrogen gas. So this one is in aqueous, okay? Then this one is also in aqueous. Okay, so now they want us to use the oxidation number method to balance this redox what equation. So now the first thing that you do in oxidation number method, so I'm going to write oxidation number method here on top. I'll write it this side. So oxidation number method. Okay, so oxidation number method. So now, when you're dealing with oxidation number method, the first thing you do is that you're going to assign the oxidation state of each uh, element on this on this equation. You're going to start with aluminium. You go to each element for each for example, here we have sulfuric acid. Sulfuric acid contains a number of of elements. You have hydrogen, sulfur, and oxygen. So we're going to assign oxidation numbers for each. Then we have aluminium. Okay, aluminium here. Again, on the product side, we have sulfur again, oxidation, or oxygen, and hydrogen. So we're going to start. So now, according to redox equations, when assigning oxidation states, okay, oxidation numbers or oxidation states, neutral atoms, for example, the way this is aluminium, the oxidation state of this one is what? Is zero. Okay. Then there are some other elements like hydrogen, oxygen, uh, group 1 elements, group 2 elements, uh, group 7 elements, oxygen, peroxides. They already have their own their oxidation states. They already have them. Okay, so for those ones, they are the most easiest ones to find. So for aluminium, because it is a neutral atom, the oxidation state will be what? Will be zero. Then when you go to hydrogen, always, okay, hydrogen in a compound like the way it is here in sulfuric acid, it is what? It is plus what? Plus one. Okay. Then for oxygen, it is what? It is negative what? 2, except for peroxides. Okay, except for peroxides. Then what you need to calculate for now is the oxidation state of sulfur in this in this equation. So what do you do? So you want to calculate the oxidation state of sulfur in this equation. So you just get the entire, you get the sulfuric acid. You're going to get it. So sulfuric acid, which is like this. Then remember that it was just sulfuric acid, didn't have any symbol. So this one, you're going to break it down. You're going to break them down into individual atoms, which will be here we have two hydrogens. So we're going to write two hydrogen plus, here you have one sulfur, so plus sulfur, then plus 4 oxygen. Okay, is equal to what? Is equal to what was the power of this entire compound? It was what? It was 0. Okay, then here where there is hydrogen, you already know the oxidation state of hydrogen. So it's going to be 2 open brackets plus 1. Okay, that's the oxidation state of hydrogen. Then plus sulfur, which is what we are finding for. Then plus 4. For oxygen, we already know that it is what? It is negative what? Negative 2. Then it's going to be equal to what? To 0. Okay, then 2 times positive 1, that will be 2, plus the sulfur, plus, so positive 4 times negative 2, that will be minus what? Minus 8, which is equal to what? To 0. Then 2 and negative 8, they can subtract. So 2 minus 8, that will be negative 6. So it's going to be negative 6, uh negative 6 plus what? Plus s is equals to what? Is equals to 0. Then the 6 goes this side. It's going to be s is equal to what? To positive what? To positive 6. So in this compound, sulfur has an oxidation state of what? Positive 6. Okay, Then now when you go to the product side, uh so here aluminium is in the compound, so you can't just say no, this one uh it is zero. No, because it's part of the compound. So, and you know that this one is group 3 elements. Okay, so even here you're going to do this as the same thing. uh Here you already know that this is a group 3 element. Okay, so this one has an oxidation state of plus what, plus 3. Then for sulfur, you need to calculate for it. Okay, oxygen, you already know that it is what, it is negative what, negative 2. So from here you do the same thing, you calculate for sulfur again. Okay, so for sulfur, you do the same thing what we did. We say 2 aluminium. Okay, 2 aluminium plus 3 sulfur, then plus 4 oxygen is equal to, what was the power? It was 0, so it is equal to 0. Then here we have 2 aluminium, so it is 2 aluminium, it is 3, positive 3, plus the sulfur which we are finding for 3 sulfur, then plus 4. Okay, then oxygen, it is negative what, negative 2, which is equal to 0. Okay, then this will be 6, this will be plus 3s. Okay, okay, so this will be plus 3s, then minus 8 is equal to 0. Okay, then 6 and 6 and 8, 6 and 8, you know that that's going to give you what? Oh, sorry, yes, yes, I'm sure that hand which has been raised, it's for the same thing. Okay, so I've made a mistake here on the oxygen part. Yes, anyone with the question?
Sir,
Yes.
there on aluminum on the product side, why have we put a plus 2 on top?
So this one is it's one of the group element. Like for example, group 1, group 2, group 3. Those ones most of the times they usually have the oxidation state. But we need to note this, that like things like sulfur, these they can change the oxidation state. But for aluminium, it is known that it is a group 3 element, so it is plus 3. Even sodium, you do the same thing. And also magnesium, you do the same thing. Those group elements like group 1, group 2, group 3, you can assign the group like, for example, how many elements is supposed to lose? Aluminium is supposed to lose 3 elements, or 3 ions, which is what? Plus 3. Then aluminium is supposed to lose 3 electrons, which is plus 3. Then magnesium is supposed to lose 2 electrons, which is plus 2. Sodium plus 1, like that. But things like sulfur, these ones they change. You're going to see this, you're going to see it very clearly. You see. So here, for oxygen, we say 3 times 4, which is what? 12. So I made a mistake, I wrote 4. Okay, so it is 12 oxygen. Okay, then here it's going to be 12. Then the oxygen already know that it is what? It is negative 2. Then it's going to be equal to 0. Okay. Then this will be 6 plus 3s. Okay. Then minus 24, okay, is equal to 0. Then 6 and 24, that will be what? That will be negative 18 plus 3s, okay, is equal to 0. And we know that the 18 will go this side. It will be 3s is equal to what? To 18. Then after that, you divide the 3, even this side 3, then the s will be equal to positive what? To positive 6. Okay, so even here the s is still positive what? Positive 6. So this one is positive 6. Okay, then now this is a molecule. If you check this one, yes, is a question.
How do we know that the overall oxidation state of the whole compound is equal to 0?
Okay, so how do we know that the oxidation state, for example, the way it is, it's like this. uh this is sulfuric acid, right? So sulfuric acid, if you check, it doesn't have any power to say maybe negative 1 to the power negative 1, negative 2. So when it's like that, meaning that this one is a stable what? Stable compound. So if you check here, there's nothing like to the power negative 2. For example, maybe you have something like this. Okay, so this one has a power negative 1. So meaning that the overall state of this compound is what? It's negative 1. Okay, but for this case, which we have here for sulfuric acid, okay, it doesn't have anything. So meaning that the overall state of it is what? It's 0. Clear?
Yes, sir, thank you.
All right, wonderful. So here we have aluminium 3 plus, sulfur 6 plus, oxygen, which is already known, it is negative 2. This one is already known, plus 3. Then after that, we are going to go to the other molecule for hydrogen. Okay, so hydrogen here, when you check it out, it is what? It is hydrogen in a diatomic what? Diatomic state, which is the overall state of it is what? It is 0. Okay, okay. So now we have our oxidation states assigned. Okay, so now we move to the next step. So now the next step which we're supposed to do is that we are supposed to now check which one is undergoing oxidation and which one is undergoing reduction. From this, so when you're balancing an equation using oxidation number method, okay, you do everything on the same equation. You assign oxidation states, you get a mark. After assigning oxidation states, you are going to identify which one is undergoing oxidation, which one is undergoing reduction. Once you do that, you get a mark. After that, after identifying which one is undergoing oxidation and reduction, you now check how much are the electrons being lost and how much are the electrons being gained. After that, you get a mark. Then after balancing, you add coefficients there, the factors, you get a mark. Up to you get 5 marks in total. Okay, so after balancing everything, you are supposed to get 5 marks in total. So now here you have aluminium, and then you have sulfuric acid, you have aluminium sulfate, and hydrogen what? Hydrogen gas. So now when you're balancing this one, uh you need to check which one is undergoing oxidation. So from here, anyone just to tell me which one of these elements is which one is undergoing oxidation and which one is undergoing reduction. Okay, so now don't forget this. Oxidation and reduction can be defined on three bases. Number one, oxidation is an increase in the oxidation number or state. Number two, oxidation is the gain of oxygen in what? In a reaction. Number three, oxidation. So I'm sure even four. There are four. Oxidation is the loss of hydrogen atoms from a compound or from a molecule, from anything that as long as you're losing hydrogen. Okay. Then oxidation again the what is the loss of what? Electrons. So you can define it like this. So now when you check clearly, you are seeing that here you have aluminium, okay, which was zero on the reaction side. Then when you go on the product side, you are seeing that the aluminium oxidation state has increased to what? To +3. So you are able to check that this one, okay, is undergoing what? Oxidation. Okay. Then again, when you check on the other part, you have also this one is sulfuric acid. On sulfuric acid, you are able to check that sulfur is still the same on the products, on the reactants, and the product is still +6. Oxygen is still -2. Nothing has happened to this, but there's one of the one of the atoms which has changed, which is what? Which is hydrogen. Hydrogen here it was +1, here it has become 0. Okay, so when you see this one, the oxidation state has decreased from +1 to 0, meaning that this one is the reduction process. Okay, so hydrogen has decreased in the what? In the oxidation state from +1 to what? To 0. Then we're able to see aluminium is gaining an oxidation state. Okay, because it's gaining in oxidation state, it has become what? It has become oxidized, or it has undergone what? Oxidation. Okay, clear? Are we clear? Okay, wonderful. So on the reduction and oxidation, so for oxidation, how many electrons have been lost? Okay, so you can check on oxidation. Here it was 0, then it has become +3. So meaning that here it has lost 3 electrons, because oxidation is the loss of what? Is the loss of electrons. Then now when you go on reduction, how many electrons have been what? Have been have been gained. There it was +1, then it has gone to 0. Or by how much has the oxidation state reduced? It has reduced by what? By 1. So it is just 1 electron. Okay. Then when you do that, you are supposed to balance the number of electrons gained and the number of electrons lost. Here you have 3e, okay? So you have lost 3 electrons, then here you have gained 1 electron. So you are supposed to balance these electrons. How are we going to balance them? By what factor are we going to multiply it with? Okay, so we are going to check here by the factor. So here there's 3 electrons, then here there is 1. So meaning that here we're only supposed to, for this to become 3, we're supposed to multiply by what? By 3. Okay, on the electrons, then it will become 3. Then here just times 1. Okay, so it is just times 1. So then as a result, here it will be 3e. Even on top there, it's going to be equal to what? To 3e. Okay, so now when you multiply the 3 to the electrons, it will also affect the the atoms or the compounds which are here. Okay, that means that when you multiply the 3 with the electrons, the 3 will also multiply with everything that is here. Okay, and also here. So that tells us that we're going to have aluminium. Okay, so let me write on the middle. We're going to have aluminium. Okay, aluminium, then plus 3 sulfuric acid, because the 3 will also multiply on the what? On the compound. So it's going to be plus 3, then is equal to, after that it's going to be equal to, here you have aluminium. Okay, aluminium sulfate, then here you're also going to have 3 hydrogen what? Hydrogen gas, because of the same multiplication. So again, here you only had multiplied 1, so the 1 will just multiply with everything here. Even on the aluminium it will be the same thing. So here it has undergone what? uh Reduction. So you need to be writing it on the middle, so that I didn't write it on the middle that side. So reduction of what? 1 electron. Okay, then we multiplied it with 3, then it became what? 3 electrons. Okay, which were gained. Then here aluminium, it became oxidized, because this one was undergoing oxidation because it lost 3 electrons. This one, the oxidation state is 0. Okay, then here we have plus 1, then this one is plus 6, then this one is negative 2. Okay, then here we have this one is plus 3 in a compound, then here we have plus 6, then here we have negative 2. Okay, then here we have 0. Okay, so we're able to check that. As a result, here you have 3 electrons, 3 electrons, then the 3 has affected this equation or this compound and also this compound. Then after that, when that happens, you just now start checking which of these atoms have not been balanced. So when you check very well, you're going to see that here you have 1 aluminium, then you have 2 aluminium. So you just the last thing you do after you've balanced with the electrons by multiplying the 3 there, because now you need to start inspecting, is the equation balanced? Okay, so through inspection you're going to discover that here you have aluminium, which is 2, then here you have aluminium, which is 1. So you just add a 2 on aluminium at the start. As a result, you have the balanced equation, which is 2 aluminium. Okay, 2 aluminium plus 3H2SO4. Okay, is equal to uh aluminium. Okay, 2 plus 3H2. Okay, then you even add the state symbols. Yes, you are free to ask your question.
Are the oxidation states of the product supposed to be equal to the reactants?
The oxidation states. Okay. Okay. So
Yes.
for okay. So the oxidation states, they are helping us to identify which one is undergoing oxidation and which one is undergoing what? Reduction. So For some of them, they will be equal. For example, you're able to check that for some elements of this compound, for example, sulfur, it is +6. Even on the product, it's still +6. Oxygen is -2. Even here, it was what? -2. Then hydrogen has changed, okay? Because hydrogen has changed, it has increased in its oxidation state from +1 to what? To 0. Okay, so this one has undergone reduction. So then for aluminium, it has moved from 0 to +3. So because of that, aluminium has undergone what? Oxidation. So these oxidation states, for some of them, they are going to be equal. Then for some, they are going to be different because they will be identifying that this compound or this reaction is undergoing what? Oxidation or reduction. Then now, what is supposed to balance is that the number of electrons, because you know that, don't forget this oil rig, okay? Oil rig. So oxidation is loss of electrons, reduction is gain of what? Electrons. So that being the case, here we have this one has undergone what? Reduction. Then this one has undergone oxidation. So the one which was undergoing reduction, it has gained 1 electron. Then the one which was undergoing oxidation, it has lost 3 electrons. So that being the case, the number of electrons gained must be equal to the number of electrons what? Lost. As a result, we're supposed to balance the number of electrons which are lost, which was what? Which was 3. Okay, so the ones which are lost, so they were 3. Then the ones which were gained, it was only 1. So as a result, we're supposed to multiply the ones which were gained by 3 so that they can be what? They can be equal. Clear?
Yes, thank you, sir.
You're welcome. So that is, so you're able to check that this equation is balanced. So that's using oxidation number method. Okay, so there's another one here, which is you also do the same thing like we did. Okay, so we have PBS, we have oxygen gas, then here we have PBO, and we have sulfate here, so sulfur dioxide. Okay, then you need to assign oxidation states first. After assigning them, you know that this one oxygen here, it is what? It is 0. Then here you find out that here it will be what? uh Here the PB will have its own oxidation state. This one will also have its own oxidation state. Then here you have sulfur dioxide, oxidation state. As a result, you are going to have your final answer. Okay, so if we to solve this, it's going to be PB. So PBS, which is lead sulfate. Okay, so PBS plus oxygen gas, it is, oh, let me write it on the middle. So P P S PBS plus oxygen, which is 2. Okay, it's gas. Then we also have, here we have PBO. Okay, then plus sulfur dioxide. So even here you do the same thing. You calculate the oxidation state. Okay, So you know that this one is oxygen is what? It's zero, okay? Because it's a molecule. This one, oxygen gas. Okay, then this one is a solid. Okay, here, so you're able to check that this is PBS. So group 6 elements like sulfur, then you have PB. So PB is lead. So lead, it has a valence of what? 2. Okay, so you're going to get the lead. So you know that this one, it is plus what? Plus 2. Okay, then this one, in the overall is what? Is 0. You do the same thing, PB plus S, okay? PB plus S is equal to 0. Then you know that PB, it's plus what? Plus 2. Then plus S is equals to 0. Then you're going to have your S being equal to what? To negative 2. Okay, so here you have negative 2. Then you have 0. Then for PB here, this side, it is still the same thing, because here oxygen, we already know that it is negative 2. So again, you do the same thing, PB plus oxygen is equal to 0. Then we know that PB is what? PB is, uh, oh, we're finding for PB. Okay, so we're trying to check for PB because we already know what this is going on in what? In oxygen. So it's going to be negative 2. Then PB then is equals to 0. Okay, so the PB is still the same as what? As plus 2. Okay, so even here it's plus what? Plus 2. Then when you go to sulfur, sulfur, you do the same thing, S plus 2 oxygen, okay, is equals to what? Is equals to 0. Then you have S plus 2. Oxygen is negative 2 always, for as long as it's not a peroxide, is equal to 0. As a result, your S will be equal to what? To plus what? Plus 4. Okay, so here your sign, here you have plus 4. Okay, then here on oxygen you have negative what? Negative 2. So now after checking here, you are going to identify which one is undergoing oxidation and which one is undergoing reduction. Okay, so here oxygen was 0. Okay, then here it has become negative what? Negative 2. So you're able to check that the oxygen is undergoing what? Is undergoing it is undergoing yes, you're free to ask.
Could you repeat on how? Could you repeat on how you found the oxidation state for sulfur?
Oh, for sulfur. Okay, so I
Yes.
said sulfur plus 2 oxygen, because there is only here there is sulfur dioxide. So I said S plus, here there are 2 oxygen, so it's going to be plus 2 oxygen is equals to 0. Then S plus 2, then open brackets, oxygen is what? It's negative 2. As long as it's not a peroxide, this one is sulfur dioxide, so it's not a peroxide. So it's going to be plus 2, open brackets, negative 2. Then close, it's going to be equal to 0. Then your sulfur is going to be equal to plus 4, because here it will be negative 2. Then uh, so it's going to be like this. S is equals to S minus 4 is equals to what? To 0. Then the 4 will go this side, it becomes what? Positive. Clear?
Yes, sir.
All right. So here, you're going to check which one is undergoing oxidation and which one is undergoing reduction. So oxygen is undergoing what? Reduction. You can see that clearly, because it has this one is undergoing reduction. It was what? It was 0, but it has become negative 2. Okay. Then for Sulfur, when you check sulfur very well, it's -2 here, then here it's +4. So it has increased in oxidation state. As a result, this one is undergoing what? This one is the one which is undergoing what? Oxidation. Okay. So by how many electrons uh, has it been oxidized to? Okay. So this one was -2. Okay. -2. Then from -2 it went, so -2, -1, 0, 1, 2, 3. Okay, 4. So meaning that it has gained, it has lost how many electrons? It has lost 6 electrons. Okay, the sulfur has lost 6 electrons because it was from -2 to positive what? +4. So it lost an electron, it became -1. It lost another electron, it became 0. It lost another electron, it became 1. It lost another electron, it became 2. It lost another electron, it became 3. It lost another electron, it became 4. When you check the difference, which is here, it is what? It is 6. Or you can just say 4 minus -2. Okay, so the difference between this is 4 plus what? Plus 2, which will be equal to what? To 6. So it has lost 6 electrons. Now for reduction, by how many electrons has it gained? It has gained by what? By 2 electrons. Oh, sorry. So you can check here. For oxygen there are 2, right? There are 2 for oxygen. There is another one oxygen here. So meaning that oxygen has lost how many? 4. Okay, 4 electrons, because here there are 2, again here 2. So when you combine them, you find out that this side it's what? 4 electrons, which it has what? Been reduced to. Clear? Are we clear, everyone?
Yes,
Okay,
sir.
yes. So because they are 2, you can check there is one oxygen here which has become -2. Again, there's another oxygen which has become negative. So you combine them. So there is -2, -2. As a result, they are 4 electrons which have been what? Which have been gained. Okay. So oxygen has gained 4 electrons. So don't neglect, because this one and this one they are separate. No, you combine them because they are on the product side, and they are what? They are uh they are together on the product side. So they are on the products, in short. So it will be 4 electrons. So now for you to balance these electrons, by what factor are you going to multiply this equation? Here you have 6, then here you have what? Here you have 4. So the easiest way to do this is just multiplying by the, for example, here there is 4, so you're going to multiply with what? With 6. Okay, then here there is 6, you're going to multiply with what? uh with uh with 4. Okay, so this 4 is affecting this equation and this equation, then this 6 is affecting this and this. Okay, so once you do that, when the 4 multiplies, it's going to be 4. Here you add your 4, then even here it's going to be what? 4. Okay, then here when you multiply the 6, it's going to be 6. Even here going to be 6. Okay, then when you check this equation, you can check that what we've multiplied it with. For example, here there is 4, 6, 6, 4. You can check that these numbers are even, so you can just divide throughout, because we don't want to have factors on the balanced equation. So you just you look for a common factor, which is what? 2. You divide this by 2, and this by 2, and this by 2, and this by 2. As a result, you're going to have an equation which will be what? Which will be 2p B S plus 3 oxygen because it's all 6, okay, then is equal to uh it's equal to, well, again this is 3 again, so it's going to be 3 P B O, okay, a plus 2 uh sulfur dioxide. Okay, this is solid, this is gas, okay. Okay, then the PbO, that was what, so it was also solid. Yeah, it was solid. So this was also solid, okay. Then you have the sulfur dioxide, which is what, a gas, okay, like that. Then you have your balanced equation. You check every atom here is balanced. Pb, there's 2 Pb, uh okay, so here there's 3, let's see, oxygen here there's 10, 2 sulfur, 2 sulfur, okay. But let's check the oxidation states. Okay, so this one is plus 2, negative 2, okay. Then here we have 0, okay. Then here we have plus 2, then here we have oxygen, which is negative 2, then here we have sulfur, which is plus 4, okay. Then this one is negative 2, so here we have 6 Pb, here we have 2, okay. Then we have uh 2 sulfur, okay. Maybe I've gone somewhere wrong. Mm, or maybe let's change the factor which we've multiplied it with. Let's change the factor. Let's use a more smaller factor. So here you have 6 electrons, here you have 4 electrons. So for us to change this to, for example, you have 6 electrons. So for you to change this, let's multiply it with uh, but no, this is the process. This is the process. Sure, maybe it's just somewhere we've gone wrong. Yes, this is the process. 4 sulfur, 4 sulfur, 6 Pb. Okay, this equation is not balanced. It's not balanced, not balanced, not balanced. But I'm sure you've gotten the process, right? The key thing is knowing the process. So I'm sure it's just on the factor which we've used to balance it. Let's change the factor, then we're going to have a correct answer. So let's change the factor which we've multiplied it with. Can even use a fraction if possible. So you have 4 electrons here, and here you have 6 electrons. So what factor are we going to multiply it with? So mm, let's use inspection to balance PB and PBS. Okay, so that's where the issue is coming from. Okay, uh, let's go to another question. So, but I'm sure you've gotten the process, right? Okay. So the key thing is knowing the process. So because I also have to teach you on half cell reaction method. Okay, half cell reaction method. Okay. So uh, when you're solving a half cell reaction method, okay. So the half cell reaction method, it is the one where you separate them. Okay, you separate the oxidation equation half cell reaction and also the reduction half cell reaction. After doing that, and this is the most common used and it is the most recommended one. Okay, because uh, challenges are not that a lot on such type of uh, equations like half cell reaction method. It's very simple and it's straightforward. Okay, unlike the oxidation number method, like for example, uh what we've encountered on the second question. Okay, at the end we found out that we have what we have failed to balance the equation. Okay, so uh for half cell reaction method, the first thing you do is that you balance the equations, like you balance some atoms. For example, you balance these normal atoms like chlorine, iodine. For this question, we're going to first balance the iodine and the chlorine. After balancing them with using numbers, for example, coefficients, then after doing that, we're going to balance the oxidation or the oxygen molecules and the hydrogen molecules. Okay, so now this half cell reaction, they will specify balance it using the half cell reaction maybe in an acidic medium or a basic medium. Okay, so when you're balancing in an acidic medium and in a basic medium, okay, in an acidic medium or a basic medium, you're going to start with acidic medium. If for example they tell you to balance it in basic medium, you start with acidic medium, then you go to what, to basic medium. Okay, I'll explain everything time allows us. So let me start with one question. Okay, then uh I'll leave the second question so that because I don't have enough time. Okay, so the first question is saying that use the half cell reaction method to balance the following equations. Okay, so you have a, okay, So for A, it is for A it is minus aqueous, okay, plus iodine, which is negative, also in aqueous. Then it's going to be equal to uh, iodine, which is a solid at room temperature, plus chloride, which is in aqueous. Okay, then after that they tell you to balance. So the first thing you're going to do on half cell reaction method, you're going to first balance the atoms. For example, uh, you have here you have you have two iodine this side, then here you have one. So you multiply this by what? By 2 to balance the iodine. Then after doing that, you are well and good. You've balanced uh the iodine and it's fine. Then now when you check here, uh there is what? There is chlorate. This one is ClO3, then it has minus. When you check the oxidation number here, okay, for chlorine, okay, for chlorine, it was what? You know how to calculate the oxidation number. I've shown you in the other question. So chlorine or chlorate is equal to, when find oxidation number, is going to be Cl, okay, plus 3 oxygen, 3 oxygen to the power, oh sorry, so this is the question you are asking. So it's going to be chlorine plus all 3 oxygen is equal to what? -1, because the overall it's what? It's -1. Then here you know that chlorine is a group 7 element, so you already know the what? The oxidation state of it, it's what? It's uh it's negative. Oh, sorry, not for this case. Okay, not for this case. So we already know for oxygen for this case. Okay, oxygen, these ones for chlorine they can change, but for oxygen, as long as it is just oxygen and not a peroxide, for example, it's just oxygen, either a peroxide or just oxygen, we already know what it is. It is what? It is -2. These are the fixed ones. Okay, so it's 3 times what? 3 times 2 for oxygen, then the chlorine will come back because we are finding for chlorine here. Okay, so because we want to check if chlorine was undergoing oxidation or reduction, because here we're able to see that it is chloride, it has a -1, it's alone, and it has what? Chloride. Then after doing that, you're able to check chlorine plus 3 oxygen, it's going to be equal to what? To -1. Then after that, it's going to be chlorine minus 6 is equal to what? Equal to -1. Then the chlorine will be equal to what? To 6 minus 1. As a result, the chlorine is equal to what? To 5. Okay, so you're able to check here that chlorine here it was plus what? Plus 5. Then this side it has become -1. Okay, so you're able to see that the chlorine is the one which is undergoing what? Oxidation. So now we've identified the equation which is undergoing oxidation. Okay, And always know this: as long as in a reaction there is reduction or oxidation, you should always know that in every reaction there can either be oxidation, there is always oxidation and reduction. So in this case, we've identified that chlorine is undergoing what? Oxidation. So we're going to write the oxidation half cell reaction. So we're going to write oxidation. Then for the oxidation, it's going to be uh, chlorine or chlorate. This, it has been changed to what? To chlorine. Okay. Then here, for the second one, you have the reduction. Okay, the one which is undergoing a reduction. So the one which is undergoing reduction, it is what? Uh, it was -1. Oh, sorry, not reduction. Sorry. Made a mistake. So when finding the chlorate to chlorine, what is happening here? What is happening to the oxidation state? Anyone? Here it was +5, then here it has become -1. What has happened? Is it oxidation or reduction?
Reduction.
Yes, so it has reduced. So I swapped them. So then for iodine, so I'm going to write oxidation. What's undergoing oxidation is iodine, because iodate it was 2I. Okay, it was being converted to what? To iodine. Okay, which is like this. Then for the reduction one, the ones undergoing reduction, for the reduction one, it was uh, ClO3. Okay, it was being changed to what? It was being changed to chloride. Okay, like this. Okay, so now we've identified the reduction and the oxidation what? Reaction. So now for the oxidation one, we just check. Okay, because don't forget, oxidation is loss of electrons. So whenever we find the difference in the electron on the left and the right, for oxidation we're going to add it to this side. Okay, then for reduction we add it the other side. So here we have the iodine is already balanced. Okay, we've already balanced the atoms of the iodine. So the oxidation reaction, the atoms are already balanced. But on the reduction, we only have chlorate, which is chlorate 3, then there's minus, is equals to chloride ion. Okay, so for chloride ion, you identify that for the chloride ion, you need to balance, there's oxygen here. So now how do you balance oxygen? Okay, so when you're and they've said that this one we are balancing it in what? Acidic medium. Okay, acidic medium. When you're balancing another acidic medium, you balance the oxygen molecules with what? With water. Okay, then you balance the hydrogen atoms with hydrogen ions. Okay, so here we have uh chlorate with 3 oxygen. So how many water are we going to add? We're going to add plus 3 water on the reduction reaction here, 3 water, so that we can balance the oxygen, because it is 3 oxygen. If you check now, you have 3 oxygen, but the difference again, which we have found ourselves in, or we have found ourselves that we have now 6 hydrogen here, but here we don't have any. So for us to balance this, we need to add how many? 6 hydrogen ions. Okay, then when you do that, you're going to have uh, the balanced atoms. Okay, you're going to have the balanced atoms. So now, after you have the balanced atoms, now you find the difference in ion. Okay, this side there is zero. Okay, the total, the overall of this side, it is what? It is zero because you have only this one. So the overall is zero this side. Then this side, the overall, it is what? Negative 2. So you subtract 0 minus negative 2. It is what? It is 2. The difference is 2. So that difference that you find for the oxidation reaction, you are going to add it where? Here. It's going to be plus 2 electrons. Why? Because oxidation is loss of electrons. So you're going to say that 2 iodate has lost 2 electrons and it has become iodine, okay, which is a diatomic what? Molecule. Okay. Then now for the reduction reaction, you count, you check. Yes, you're free to ask.
How do we know that? How do we know that the oxidation state of iodine is -2?
Okay, so for example here, we have okay, so here we have a negative iodate here. So the overall here it was -1, right? But we balanced it with a 2. So this 2 multiplies with a 1 here. The -1, it becomes what? -2. As a result, you subtract the product minus this, it's going to give us what? It's going to give us plus what? 2 electrons. Clear?
Yes, thank you.
All right. So now, then when you go to the reduction reaction, this one you have, when you calculate the overall, so here you have 1 and here you have 6. So it's 6 times 1, so it's plus 6. Then here you have -1. So it's going to be 6 plus what? Uh, it's going to be 6. This side is going to be 6. Okay. All right. So here it's going to be 6 plus -1, which is plus 5, right? So it's going to be plus 5. 5 electrons this side. Okay, it's going to be 5 electrons this side. Then here, when you check the overall of it, there is 0. Okay, and there there's -1. So when you add these two, it's going to give you -1. Then you subtract. You find this the difference. So it's going to say uh you're going to say -1 on the product, minus, because you want to check the difference of this, minus positive what? Positive 5 on this side, which is going to give us what? Negative what? 6. So this is telling us that uh the difference here is what? It is negative, or let me just say it is 6. Okay, so where are we going to add the 6? For a reduction reaction, because that's why we're finding negative, because when we find negative, meaning that it's supposed to be minus 6 electrons this side. But for the sake of just to just put the electrons on the other side, so that even this sign doesn't supposed to become a negative, supposed to become a positive, you are going to put the electrons here. Okay, it's going to be plus 6 electrons on the left side. Okay, but it's still okay when you write them this side, it's still fine, you still find the correct answer. But let's do this because that is what is usually done. Okay, clear? Are we clear? All right, wonderful.
Yes.
So here, when you have this, you're going to now balance, okay, the electrons on the, you're going to balance the electrons on the reduction and oxidation reaction by multiplying. Okay, you're going to multiply. Uh, you're going to multiply. Here you have 6. Here you have what? You have 2 electrons. So you're going to multiply this equation by what? By you're going to multiply this equation uh, by 3 so that the electrons can become equal. Then this one by what? By 1. Okay. When you do that, it's going to be oxidation. Okay. Oxidation reaction is going to be 6 iodate. Okay. Then it's going to be equal to 1 iodine plus 6 electrons. Okay. Then here you're going to have on the reduction, you're going to have chlorate. Okay. This plus 6 H plus, then plus the 6 electrons. Okay. Then it will give you chloride plus 3H2O. Okay. After having this, you know that the electrons here, they are on the right side, but on the reduction, they are on the left side. So they are going to do what? To cancel. Then you combine the two equations. As a result, you have an overall reaction, which is you get this one, which is 6. So 6, okay, plus the chlorate, which is ClO3 negative. Then you get the hydrogen ions because they have remained here. It's going to be plus 6H plus, then it's equal to, then you have this one on the right side, you have iodine. Okay, you have iodine. Okay, which is supposed to be 3 because you multiplied with 3. Okay, on top here, I think I forgot to write it there. Here it will be 3. Okay, yeah, I wrote it. Okay, it's here 3. Then here to also be 3 iodine. Then plus the chloride. Okay, plus 3H2O. Okay, then you have your balanced equation in what? Oxidation, or in acidic what? Medium. Now you have the hydrogen ions. If you try to calculate how many atoms there, here you have 6 iodine, iodate, you have 6 iodine, even here. So you have 6 iodine, you have chlorine, 3 oxygen, 6 hydrogen plus hydrogen, 6 hydrogen here. They are all balanced, and you have the balanced reduction and oxidation equation like this. Okay, that's your final answer. This is in acidic what? Acidic what? Medium. So now I'll just use this example, to the same one, to solve also for basic, so that we don't waste a lot of time starting to solve again. So every time when they tell you to balance a redox reaction in basic medium, the first thing you need to do is to balance it under acidic conditions. Then after finding the final answer, what you do is that here, like the way we found, right? Now, if they say in basic medium, after we reach this point, we are supposed to add uh hydroxide ions on both sides. Okay, depending on how much hydrogen we have. So looking on this equation, we have 6i chlorate, then plus we have the 6 hydrogen. So we are going to add 6 hydroxide ions on both sides. When we do that, we are going to have uh you're going to have 6 I, then plus the chlorate. Okay, let me just be quick. Plus the 6 hydrogen ions. Okay, so the 6 hydrogen ions, when you add 6 hydroxide ions, okay, it's going to cause these to join and form water. Okay, then this becomes like this. Then this side again, it's going to be 3I2 plus chloride, okay, plus 3H2O, okay, plus the what? The hydroxide what? Ions again on this side, which are what? Which are 6 to balance everything. Okay. So now, when you add 6 hydroxide ions this side, even this side, 6 hydroxide ions, this side, because they are hydrogen ions, they are going to react and form 6 water. So it's going to be 6 iodide plus Cl3, which is chlorate, okay, then plus 6 water, okay. When that happens, is equal to 3 iodate plus iodine plus chloride ion plus 3 water, okay, then plus 6 hydroxide. When that happens, when you have this, uh, after having this, you're going to discover now that here you have 3 water, you have 6 water. So these waters can subtract, because this one is on the right side, this one is on the left side. So when you subtract, you're going to remain with 3 water on the what? On the left. As a result, you're going to have 6. Oh, sorry. So 6 iodate plus chlorate. Then this one is going to be plus, because they've subtracted, it's going to be 3 water. Okay, 3 water is equal to 3 iodate or iodine plus chloride plus 6 or H, because the water which was this side has subtracted this one, and then there's nothing this side. As a result, when you check out this side, this one now is in what? It's in basic medium, because it has the hydroxide. This one was in acidic because it had the hydrogen ions. Clear? Clear? Okay. So that is how you balance equations. So the half cell reaction is easier. Okay. It is very, very easy for you